right, guys. Well, we've got 9 of the 11. I'm not sure who's missing, but they'll have to catch up on video, I guess. But let me see if I can't get our screen going here with our. Here it comes. All right. So this is 0B this morning. Okay, let's go to our grade screen and scroll way down to the bottom. Oh, I've already done the assignment for this week for 0B. Look at that. I already got mine turned in. Graphing logarithmic functions is this week, 4.07. And then the semester exam is next week. So we have one lesson that's due this Sunday, graphing log functions, 4.07, and semester exam. If we go here and look, module 4, here's our lesson. If you go to the semester exam, it's there. You just can't get to it yet because it's not time. So while we're on that subject, this is a class you can be exempt from. But if you are not exempt, or even better, if you are exempt but want to raise your grade, you can take the final. And if the final helps your grade, then I'll put it in. If the final does not help your grade or hurt your grade, I just act like you never took it. I just totally exempt it, and you don't have to take it. So that's only if you are exempt. If you're not exempt, the final counts. Either way, helps your grade, hurts your grade, it counts if you're not exempt. So I will tell you next Monday, because we will have class next Tuesday. Monday, I'm going to send all those out because I have to get the attendance report, and I'm giving everybody until Monday morning at 7 a.m. to get any missing assignments turned in. Now, this class is not filled with missing. It's not like there's 40 missing assignments between everyone in here. Almost everyone in here has everything turned in. There's just a few people that are missing some assignments. And I got till Monday at 7 o'clock because one of the things to be exempt is you can have no missing assignments. That's one of the things. No missing assignments. A grade has to be 75% in the class or higher, which if you got everything turned in, your grade's probably 75% or higher because you guys are doing great. Cannot have more than 4 absences or 4 tardies in this class. And then the big one, no more than 4 absences or 4 tardies in 6th period, your advisory, 6th period. So you can't have more than 4 absences in there. So if you've been skipping advisory, well, then you have to take all your finals. You can't be exempt from anything. So that's the big one. But if you want to take the fun, ours is Friday. So ours is next Friday at 7:15, our normal class time. And you'll have an hour and 55 minutes. It goes 7:15 to 9:10. It won't take an hour and 55 minutes unless you fall asleep in the middle of taking it. It's not that many questions. I think it's 20 or 30 questions maybe. But still, like an hour and a half. Almost 2 hours, hour 55. But it is Friday at 7:15. So, yeah, next Monday I'll send out we are having class next Tuesday. We're not having a lesson. We're not putting more work on you next Tuesday, but we will have class. And we'll probably talk about the final then for those who are taking it, but I'll see what else I can come up with for class. But we will meet. But if you're exempt, you don't have to take it, but you can if you want to try to boost your grade up a little bit. All right, got that. Let's go back to our 4.07. Graphing log functions. So, I need to open up Desmos for early graphing. All right, Desmos is opening. There. Okay. What do you remember about graphs? Oh, I'm going to open up the chat so I can get some responses on this. All right, let's see. What do you remember about graphs and their reflections? In the picture shown below, we're going to select the picture that represents the image given being reflected across the indicated axis. So let's see. I'm going to try to make this a little bigger. I don't know if I could keep them on the screen. Yeah, that's probably as good as it gets right there. Okay, so here's our picture right up at the top, the biggest picture. And we're going to reflect this over an imaginary y-axis. Let's pretend there's a y-axis next to this picture. And we're going to reflect it over the y-axis. So looking at the pictures below, this one is going to be A right here on the left. This one's going to be B. The bottom row is C and D. So left to right, top to bottom, A, B, C, D. Which one of these pictures below would be a reflection of this picture over an imaginary y-axis? a y-axis. A, B, C, D. Y-axis. You can see those. If you have a graphing calculator, yes, you can use a graphing calculator. If you can use Desmos or a graphing calculator or the calculator that's in Buzz on the final. Absolutely. All right, I'm seeing, I saw a few C's at the beginning, but then it switched to B's because if this was a y-axis, the y-axis is the up and down axis. So if we reflect that, yeah, it should be the B. Let's see, submit. Yes, there it is. The y-axis is the up and down, so it would reflect this way. All right, we've got another one. Actually, we got 3 more, so I'll leave it big. Okay, this is over a y-axis again. A y-axis again. Which one of the below, A, B, C, or D? A and B is on the top row. C and D is on the bottom row. Reflecting this over the y-axis. Oh, I see several people weighing in. Who else is weighing in here? A, B, C, D. Some of these don't even make sense. It wouldn't. That would be a rotation right there. A doesn't make any sense at all. Yeah, it should be D, right? That would be reflecting with this on to a y-axis. There it is. That's right. Okay, now we're going to switch to the x-axis. So, this was a little tricky. I had people miss this one yesterday. So, if we reflect this image over an x-axis, is it going to be A, B, C, or D? People missed this one yesterday. This was tricky. Oh, I've got different answers today here. I've got A's and C's. Oh, Mary changed hers. Mary had A, and now she changed it to C. Nautica also changed hers. So now we're all C's. Right, you got to pay attention because this does go upside down like an X, but you notice these two guys trade places. So it actually reflects over the Y and the X. That reflects over both of them because they trade places and then go upside down. So it is C. Good job. A couple of you were fooled at first, but you corrected yourselves because you looked at it again and went, wait a minute. Submit. Yes. Because everybody should be in the same order, just upside down. Let's see, number 4. It's our last one. Got this puppy dog being reflected over the x-axis again. Oh, stop, puppy dog. Whatever. X-axis. Which one of these reflects that puppy dog? A is the top left. B is the top right. C and D are on the bottom. A, B, C, D. Puppy dog reflected over the x-axis. Yes, A. I see lots of A's. Puppy dog, we just reflect straight down right there. And we are correct. We can put the puppy dog upside down in the right place there. All right, we can shrink this back down. That was our 4th. Good job, guys. So for this lesson, we're going to be able to answer these questions. How can logarithms be graphed with different bases? And how do transformations affect the log graph? So graphs of logarithmic functions. So now that we've practiced working with reflections, we may recall that the graph of a log function is simply just a reflection of its exponential function counterpart across the line y equals x. So let's look at that on Desmos because it's a bigger graph than the little bitty ones they give in the lesson here. So if we have y equals 10 raised to the x, that's an exponential equation. All right, that's here. We'll zoom in a little bit more. Oh, I'm going to get rid of those minor lines. I don't like the minor lines. Confuse things. Okay, so here is the exponential equation, 10 raised to the power of x. The counterpart, the accompanying logarithm, and if we rewrote this equation as a logarithm, y equals log of x. This is base 10, right? Because I don't have a base there. And can you even put a base on Desmos? I haven't looked at that. Functions. Where's the log of functions? Oh, it does have log A. You can use Desmos to put a different base, but we're going to learn another way to do a different base. So this is log base 10 of x. This is the logarithmic equation. Notice it has 0, 1, 1, 0. This is a reflection over the line y equals x, that green line right there. So every point you find here, you can find the equivalent point over here swapping the x and y. 0, 1, 1, 0. Let's see if we got a point. Let's see, that's 0.602399999, which means there should be like a 3.999. All right, gotta zoom in right just to get it. But anyway, the accompanying point is over here, switching the x and y. All of these points move over here, and you replace the x and the y with each other. It's a reflection, and they show that here it's just a lot smaller. If we want to see additional characteristics, let's look at more characteristics of the graph of the common logarithm, which is what we just have on Desmos. So the domain of an exponential function is all real numbers, right? When we look at let's turn off this one. The domain is all real numbers. The x's go from negative infinity to infinity. Now, it takes a long time to get to infinity because it's going up so fast, but it keeps going to infinity. And the range is y is greater than 0. This never touches the y-axis. It looks like it. It gets really close. It thinks it does. But if you zoom in, it'll figure out, wait a minute, that's actually not touching. It said 0 a minute ago. Now it says 0.000002. So it never, ever touches the y-axis. So the range is all y's greater than 0. Not greater than or equal to 0, but all greater than 0. That makes the x-axis an asymptote. While the graph of the general log function may not appear to pass the vertical line test. If we switch to that one, so it looks like, oh, that's going to fail the vertical line test. No, actually, it never gets perfectly straight up and down. This is just like the exponential never touches the x-axis. This never touches the y-axis. It never gets to x equals 0. It looks like it. See, it says it's undefined right there. It says, wait a minute, that's 0. It's undefined. It has no slope. But when we zoom in closer, oh, look, it does not touch the x. It's not straight up and down. Getting closer, you start to see a gap there. Oh, yeah, look at the gap. But when you zoom out, it thinks, oh, no, this is just 0. It's not 0. The x is not 0. So this has a domain of x is greater than 0, right? It would never have x equal to 0. We never have a negative x. And then the range is from all real numbers, negative infinity to infinity. So it's just the opposite, which we would expect since a reflection over y equals x. So the x values of a log function, similar to the y values of an exponential function, become progressively smaller, but will never be less than or equal to 0. So the y-axis is an asymptote for a log function. So since the domain of the exponential function is all real numbers, that means the range of the log function is all real numbers. So here's a little chart that just kind of summarizes that. The domain, the range, and the asymptote. For an exponential function, all real numbers and y is greater than 0. X-axis is an asymptote. For a logarithm, it's just the opposite. X is greater than 0, y is all real numbers, and the y-axis is the asymptote. So up to this point, we've really only explored the graph of the common log, which is base 10. So let's look at how changing the base of log functions affects its graph. So technology is usually programmed to just graph the common log. Desmos does give us an option to put in a different base, but let's act like it didn't. So any graphing that you're doing, you could do this without having to worry about whether or not it'll let you do a different base. Like the f of x equals log base 4 of x instead of base 10. Well, we have that change of base formula that we learned for logarithms. If you have log 4 of x, you can write that as log base 10 of x divided by log base 10 of 4. And we can do the same thing in Desmos. So let's get rid of these other ones. So y equals log of x divided by log of 4. Now this looks a lot like the original one we had. Let's put the log x on there, base 10. See, it is a little different. The black one is the normal base 10. Base 4 got a different curve to it. Different curve. Let's prove to ourselves, since Desmos lets us do different bases, let's put in different base. Go down to the log right there, just to prove that is the same one. Log base 4 of x. Now look, see the red graph is the exact same graph as the purple graph. So this works. You can just type log x divided by log 4 using base 10, and that's the exact same graph as log base 4 of x. So that's handy to know. So let's change the base. I'm going to take off the red one there. Let's log base 2. See how it gets even more wide, farther away from the x-axis. The curve really changes the smaller base we get. Let's do a larger base. Let's do base 25. Base 25 actually gets closer to the x-axis. Base 250, somewhere. Log base 250 of x. Gets really, really different. It's more of a sharp curve here where it curves at and stays lower to the x-axis. So that's how we can graph different bases. So it gives you the steps right here to graph log 4 of x. Like if you have a graphing calculator, this tells you how to do it. So set up the coordinate plane by ensuring you can see the grid and the x and y axis. Enter the equation f of x equals log x divided by log 4. You got to use some parentheses there to keep it together. Using the log function, specific to whatever program you use in our calculator. For example, enter log x divided by log 4, or maybe LGX if your calculator just uses LG by LG. But there's no space between log and the x, and also the base of 4. And got to put it in parentheses. And then you should see a graph appear, and it'll show you that's log x divided by log 4. And that's how you do it on like a calculator or something, or even on Desmos. We did log x divided by log 4. Just typing it in. All right, let's go to page 2. Very short lesson here. There's only 4 pages. Let's look at some additional examples. Graphing log functions. So graph f of x equals log x minus 3 in parentheses, x minus 3. Let's see what happens, because this would be a translation, right? What's going to happen? We know what happens like on quadratic equations and, to other polynomials. If you put x minus 3 in parentheses, that shifts it right. But let's see what it does here. We're going to go ahead and go back to just the regular log base 10 of x, but we're going to put another one underneath it of x minus 3. Well, look here. Our crossing of the x-axis at 1, 0 has now moved to 4, 0. It shifted it right 3 spaces. That's exactly the same as what it does with quadratics and third power and fourth power, or just x. Every other translation that we've looked at, this would shift it to the right 3, and it does the exact same thing with logs. At least transformations, this is all very consistent. That makes it easy to remember what's going to happen. Remember, if we make this a plus 3, it's going to go into the negatives, right? It shifted left 3. So now it's crossing the x-axis at -2. So it does just what we expect it to do. When you put x minus 3 in parentheses, it's going to shift it over 3 to the right. Example 2. That says do log base 3 of x plus 2. Can we do that? Sure. If we remember how we do that, if we want x plus 2 to be the argument and 3 the base, we put x plus 2 on top of the fraction and divide it by log 3. So that's log base 3 of x plus 2. So look at that. It shifted it left 2. Instead of crossing at 1, it crosses here. And it's higher off the x-axis because it's only base 3 instead of base 10. Right? When it's base 10, we expect that kind of curve. But since this was base 3, it goes up here wider. So if we go back to the original equation again and just log base 10 of x, we started out with this one that's green. Now we've made it a little taller and we've shifted it left 2. That's what the x plus 2 does. All right, example 3. Graph log of x plus 6. The plus 6 is on the end now. Okay, so we got log of x. Let's do y equals log of x plus 6 plus 6. Oh, looky there. Exactly what we would expect. When we add a number to the end of the equation, it's not in parentheses with the x, it's just added onto the end of the equation, that will shift it up. If we subtract a number, let's do minus 3. Shifts it down. Now it's down here at 1 negative 3 instead of at 1 0. We shifted it down 3. The graph looks exactly the same. We've just moved it up or down, depending on whether this is plus or minus. Translations work exactly the same. Example 4. Now that you've seen the different type of shifts, let's discuss some patterns. So x plus 6 in parentheses is a horizontal shift, right? It moves left 6. That's what we expect. X plus 6 in parentheses moves it left 6 units. But when we do x plus 6 at the end, not inside with the x, it goes up 6. We shift the graph up if we add a constant to the log function. All right. And of course, you know, the opposite signs, negative moves right and down, depending on whether it's in the parentheses or not. So that's exactly the way it works with the other functions. So that's comforting to know. If we understand transformations, it applies here exactly the same. Example 5. Graph log base 8 of x minus 5 using technology. So that's a little different. Log x of 8. So we would do this. So what was it? Just log x of 8. So y equals log x divided by log 8. And if we want to put, is it minus 5? Minus 5. If we put minus, we have to put it at the end. Minus 5. So look, I shifted it down 5. We don't want it to be part of the fraction because that fraction was just to help us graph base 8, log base 8 of x. If we were shifting it left and right also, we would do the x plus 1 or whatever in parentheses on top of the fraction. So that'd be log base 8 of x plus 1, and then minus 5 is at the end of the equation. Notice that shifted it left and down. That's all 5. The y-intercept, you may have noticed now, but logarithms get really close to the y-axis, right? They get, without the transformation, they get really, really close to the y-axis. Like really close. But they never cross the y-axis. Just the base equation is. The only way to make it cross the y-axis and have a y-intercept is to give it a horizontal shift, right? And that's when we put the x in parentheses and add a number to it. A horizontal shift, now we have a y-intercept. Only with a horizontal shift. If the parent function's just f of x equals log base 10 of x, then the transformation of x plus 2 in parentheses will shift it 2 units to the left, just like that, across the y-axis. Now the asymptote is y equals negative 2, by the way. See, now it never touches the negative 2, but it gets closer and closer. All right, lesson summary. Look at page 2. We've got our lesson summary. Said this was a short lesson because it's all about graphing and we have Desmos. So how can logs be graphed with different bases? Did that by dividing. And how do transformations affect the log graph? Exactly the way they affect all the other graphs. So a log function is an inverse of an exponential function. So it's a reflection of y equals x over the line y equals x. The base of a function is a positive real number not equal to 1. Graphing a log function may be done using graphing technology. If you need to change the base, that's how you do that. Open the calculator, set up the coordinate plane, enter this equation, and you'll have the graph appear. General log functions have a domain of x is greater than 0 and a range of all real numbers and a vertical asymptote x equals 0. The only time that's not true is when you have transformations. When you move it up or down, left or right, that will change what's going on here. Okay, let's go to page 3. Here's some practice. Can you graph this? Log 15 of x. Go to Desmos or your calculator or wherever you want to and see if you can graph that. And then you can check your answer, see if it looks like that. There are 7 graphs here, 7 equations for you to graph. See if you can do that. So that's good practice. Let's go to look. If I go here and look at the assignment, you'll see, there's no questions. This is not one of those. This is attach your work file here, refer to the directions in the lesson. Well, let's go back to the lesson and see what it says. Page 4, the last page has the assignment. If we scroll to the bottom, here's the assignment questions. There's 2 options. We choose to work alone. We're not working in groups because we're all spread out. You can copy this and just put it on a Google Doc, but here's what it says. If you ever swam in a pool and your eyes began to sting and turn red, you felt the effects of an incorrect pH level. The acidity is off. pH measures the concentration of hydronium ions and can be modeled by the function PT equals negative log 10T. You can graph that. Y equals negative log 10. We don't have to put the 10 of T. Here is the graph they're talking about. We can use T. The variable T represents the amount of hydronium ions. The graph, PT, the Y, is the pH level. So it says water at 25 degrees Celsius has a pH of 7. That's neutral, right? Like a glass of drinking water. Anything that has a pH less than 7 is called acidic, like soda pop, right? Coca-Cola has a number lower than 7. A pH above 7 is called basic or alkaline, right? It's non-acidic. Seawater is acidic. It has a pH. Seawater is basic because salt cancels out acid. It has a pH of more than 8, so it's higher than the 7. Lemonade has a pH of about 3. Don't know how much lemon in there, so that's why it makes your mouth pucker. It's very acidic. So here's what you're supposed to do. Create a graph of the pH function, either by hand or using technology. I've already done it right here, actually. Locate on your graph where the pH value is 0 and where it is 1. Where is it 0? Oh, when the hydronium ions equal 1. But remember, T, which is the x-axis, represents the amount of hydronium ions. The Y is the pH. And where is it equal to 1? We can go up here. How many hydronium atoms? 0.1 hydronium ions will leave you a pH of 1. You may need to zoom in on your graph. So you have to mark that. Give those values. What is the value when that's there? The pool maintenance man forgot to bring his log charts, and he needs to raise the amount of hydronium ions to 0.5. To do this, he can use your graph. So use your graph to find what is the pH level if the amount of hydronium ions raised to 0.5. And then convert the function into an exponential function. So you got to go back and look at that lesson. How do we rewrite it as an exponential function? So you're going to rewrite this log function as an exponential function using Y for the pH. So then the pool company developed new chemicals to transform the pH scale. So using the same function, negative log T10 as a parent function, which transformation results in a y-intercept? Because as we looked at it, it doesn't have a y-intercept right now. But which one of these three choices will give it a y-intercept? So that's what this week's assignment is. You got to make this Google Doc and all this stuff. So that's the crazy. Now you're ready for the good news. You ready for the good news? I'm giving you an early Christmas present. I'm going to make this assignment optional.
Oh, yeah!
If you want to do it to try to add a few points to your grade, great. Then you can do that. You want to do that. And if you do raise your grade, I'll count it. If you decide, nah, my grade's good, I don't want to do it, it's optional. I won't hold you to it. I will make this an optional assignment because I want you to be studying for the final, be ready to that if you're taking that, or just get late work in if you're behind on anything. So optional assignment, guys. Woohoo! If you're missing anything, get that in. Like I said, our final is next Friday at 7:50. This is posted in Google Classroom, by the way, on the front page. Next Friday at 7:15. We will meet next week for class on Tuesday. And I guess that's about it. I don't have anything else for you. We only had the one lesson. We went through that. We looked at how to graph logarithms. You guys understand that. You saw it. You can go practice it if you like, but the assignment's optional. So as far as assignments, then you're done for the semester, except for the final, if you're not exempt. And hopefully you're exempt. I'll have the attendance report probably by Friday or Monday. But Monday, I plan on sending out the email saying, yay, you're exempt, or sorry, you're not exempt. You're going to take the final. I plan to send those out Monday. So that way you'll have time to know if you need to study or not. And remember, you can always take the final, even if it is exempt, to raise your grade. So that option's there. So anyway, you got the rest of this class period to work on anything. If you got any missing assignments, if you want to do this optional assignment, you just want to study, you haven't had breakfast, whatever it is, I'll give you the rest of this period to do that. And have a great week.